This lesson 3 video is on page 11 of 168, and it should be watched after you do lessons 1 and 2. Go figure. Okay, I'm going to start with entry task. Match the following terms to their definitions: the x-axis, the y-axis, the independent variable, and the dependent variable. I'll match 2 of them. You match the other 2 of them. That's too easy. I'll match 1 of them, and you match the other 2. I'll match the x-axis. The secondary or vertical axis? No. The principal or horizontal axis? Is that a typo? Okay. A variable often denoted by x or a variable often denoted by y. The x-axis is the principal or horizontal axis. So that one goes there. Would you go ahead and match the other 3 statements? And I'll do that right now, but you should pause, skip ahead after you've done it, and check your answers, see if they match mine. Okay, I'll wait for you. Okay, so you're done, and your answers look like mine. Let's go to the classwork, exercise 1. This graph shows how the amount of gas remaining is related to the number of miles driven. And we see that it's a function, it's a line that is decreasing over time, no, over miles. And gallons, we're comparing gallons and miles. If Jonathan drove 60 miles, how many gallons of gas would be left in the tank? So 60 is right here. Find the 60 on the graph. From there, go up to the line, and then once you find the line, go over to the left. I said right. Over to the left, it would be 1 gallon of gas. When Jonathan started driving, how many gallons of gas did he have? The fact that we asked the question when Jonathan started driving is telling us to find a specific feature of the graph. Specifically, what's the y-intercept? And on the y-axis, the y-intercept is 7. So therefore, we'll interpret that 7 as he had 7 gallons of gas when he started. Okay, last question. When will Jonathan run out of gas? If the line is decreasing as the number of miles driven increases, the number of gallons of gas goes down. I mean, that's common sense. If you're driving, the longer you drive, the more gas you use. So that makes distance driven the independent variable, and gallons left, the number of gallons left, depends on the miles you have driven. Hence, it's the dependent variable. So when will Jonathan run out of gas? I guess when the number of gallons of gas is 0, and we'll see how far away he is or how many miles he's driven along the way. Falls, 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 falls at 6, at 5, at 4, at 3, at 2, at 1, right here. When Jonathan has driven 70 miles, he will have no gas in the tank. He will have run out. Looking at a graph, interpreting the graph. Another example. Okay, so Alberto and Bianca race. We can see the hours traveled and the, taken to travel, and the kilometers that they've actually achieved in distance as they've run this race. I guess early on in the race, you can look at it between Alberto and Bianca. Alberto runs faster. Now, visually, that line is steeper. So he has a steeper line. But how do we know? In the same amount of time, comparing 1 hour to 1 hour, he runs 20 kilometers while Bianca has only run 3. Okay. So looking at 1 hour, okay, early in the race, Alberto has run 20 km. While Bianca has only run 2, approximately 2. We can see that not only from the steepness of the line, steep, not steep, to just really literally how much distance has been covered. However, after 1 hour, he gets tired. Oh, darn, this story sounds familiar. And he falls asleep. So during this time, his distance traveled is 0. Meanwhile, Bianca's distance keeps increasing. So it stays 0, stays 0, stays 0, stays 0. Uh-oh. She caught him. The first person to cross the finish line depends on the length of the race. Is there anything up here that says how long the race is? I mean, if the race is a 20-kilometer race, Alberto won it. But it's probably a 50-kilometer race. And if it's a 50-kilometer race, this line belongs to Bianca. Okay, it depends on the length of the race. If it's a 50-kilometer race, then Bianca gets to 50 at 6 hours, and Alberto gets to 50 at 7 hours. So Bianca gets there in 6. Alberto gets there in 7. And that matters. That's going to tell you who won it because of how fast or how much time it took for them to get the 50 kilometers in order to win the thing. Okay, exercise 3. Wait a minute. How many of these do you have to do? All right. I'll do exercise 3, but I'm not going to talk about it loudly. When I'm done, fast forward the video and look at that, but only do that after you did it too. 14 hours. I found 14 hours. I went up to the graph and I found the graph, and then I went to the left to find the actual dollar amount. 30. And because it's a flat rate right here, that means that after 10 hours, you're just going to pay 30. The initial fee is $8, but we have this changing line, this rise and then stop kind of function. So it starts at 8 and it's steep, and then the more you rent the bike, the less steep it is until you just rent it the whole day. How many hours would you rent? This one was kind of fun. I like asking these types of questions. This bottom one, how many hours could you rent the bike for if you had 20? It's like thinking about a budget. You have so much money you're going to spend. How far can that get you? And if you have $20 that you're going to spend, in order to figure out how many hours that'll purchase for you, take the $20 to the graph and then go down to find the hours. So it's the flip of what we've been doing. All right. Those are the lessons. Those are the example problems. You'll have the problem set to do, and I'll let you get to that in a second. Let's talk about the closing. Can you identify the independent and dependent variables? Can you identify the vertical and horizontal axes and what they represent? Can you connect points on the graph to the story or equation? And can you interpret a story problem represented graphically? Please go ahead and fill in the space, your score 0 to 5 or so. And then how can you improve? What would it take for you to be able to teach this better to someone else? All right, when you're ready, I'm going to talk about the exit ticket. I'll give you a minute. Go ahead and skip forward about 30 seconds or so. All right. Talking about the exit ticket, this is absolutely a question that we like to use in our department to, one, align your responses with the Smarter Balanced. And then two, talk about how it tells us information about things that are graphed. I'm going to make sure that I remind you about identifying key features. And one of the key features comes from, I think, lesson 1, where we look for the delivery fee. The delivery fee is the initial value. And so Sadie charges $5 per ton, plus a delivery fee of $200. On the graph, I spot $200. So therefore, and no other points, so therefore, that's Sadie's line. I'll highlight it with this pen in red. Next is the fact that Greg's Sand Pit charges a delivery fee of $50. It's the only other option, but the point is that this definitely looks like a $50 instead of a $200, so this has to be Greg. And I'll do it in blue with a G. Okay, that takes care of number 1. To explain what the intersection of the two lines of the graph represents means that's the amount of tonnage, the number of tons, where both companies charge the same amount. So for approximately 20 tons, both companies charge roughly $300. In order for you to have a solution to an equation, to have a solution to two equations, you need to look for a place where they cross on the graph. And so that's my main recommendation, is that if you have a graph, or if you can go to the graph, do it. Use this amazing website right here, desmos.com, in order to access that. All right, looking ahead, that means that you have the problem set to do. That's your homework. And my plan is that by Thursday, you have covered lesson 4 and you're ready for me to come back on Friday and give you a quiz and ask you to turn in any homework that I've given you and share with you what it is you need to do, and you're starting the trimester out right with an A. But I digress. Go ahead and after this video, get ready to look at lesson 4.